So, second part of this section, we're going to look at the substitution rule for definite integrals. And this will work the same way as for the indefinite integrals, but obviously we have limits of integration, and so that changes a little bit. But as far as the substitution mechanics go, it's not going to change anything. In fact, the first half of that is going to be the same as what we were doing in the first video. With one little added thing that we'll see as we go along. So I think we saw this one as an indefinite integral in the first video, so we'll kind of go a little bit fast through this part. So the u is the 2x plus 1, the du is 2 times dx, and then of course we don't have a 2 outside of the root to go with the dx, so we need to divide both of these by 2. And we get that du over 2 is dx. We saw that one in the first one. Now this is the part where it's different, and the little added part. So we have limits of integration. So x is 0, x is 4. So we're integrating from 0 to 4. So x is 4, x is 0. Now what is u going to be? If x is 4, u, which is 2x plus 1, is 2 times 4 plus 1, which is 9. And if x is 0, we have 2 times 0 plus 1, which is 1. So now the limits of integration become 1 to 9 instead of 0 to 4, because we're going to be working with u and not x. So now this becomes the square root of u times du over 2. All right, so let's write that in a nicer way to make it easier to integrate. And so we did this in the last one, so I won't spend a lot of time. We end up with 1/3 u to the 3/2. And now we're going to integrate this from 9 to 1. So you don't, or from 1 to 9. So you don't have to do a substitution back to x when you're evaluating limits of integration, as long as you do this part. So make sure you understand this part. This part is just whatever the two x's are in your limits here. Evaluate those values of x and see what u is when x is those values, and those are your new limits of integration. And if you don't remember this from Calculus 1, you might need to review this, but when we evaluate definite integrals, we plug in the top integral, or the top limit, and then subtract the bottom. And so we have 1/3 as a constant. We can factor that out. So we have 9 to the 3/2 minus 1 to the 3/2. And 9 to the 3/2 is 27. 1 to the 3/2 is 1. So we get 26 over 3. Okay. So that's the main new thing with the definite integral is figuring out what the new limits of integration are. And so those will go with your, when you do the substitution with u, put the new limits of integration. If you put the old limits, it doesn't work, obviously. Okay, next one, now that should not be there, so it's just dx over 3 minus 5x squared, and integrating from 1 to 2. So we will let u equal 3 minus 5x. We get du is negative 5 dx. And of course, we don't have a 5 out here, so we need to divide by negative 5. Negative 5, and we get negative du over 5 equals dx. And so let's see what the new limits of integration are. So if x is 2 or x is 1, what is u going to be? So u is 3 minus 5 times 2, which is negative 7. And when x is 1, we have 3 minus 5 times 1, so 3 minus 5 is negative 2. So this becomes the integral from negative 2 to negative 7. Now don't worry, normally you write this with the bigger number on top, smaller number on bottom. Don't worry about that it's reversed here, because as long as you're consistent, the 2 goes with 7. When x is 2, u is going to be negative 7. When x is 1, u is going to be negative 2. So it's okay. And then we end up, dx becomes negative du over 5. And then 3 minus 5x squared is just going to be u squared. All right, and then fairly easy integral to do after that. So let's write this as negative 1/5 u to the negative 2 du. Add 1 to the exponents, that'd be a negative 1. Divide by negative 1, so we get 1/5 u to the negative 1. Integrated from negative 2 to negative 7. So we have 1/5. And this would be negative 1/7 minus negative 1/2. And so we should get, let's see, 1/5, negative 1/7 plus 1/2. And 1/5. So let's common denominator. So 2/14 plus 7/14. So that's 5/14 times 1/5, which gives us 1/14. Okay, which is what we should get. Okay. All right. So more of the same as far as the substitution goes. And I hope you've seen through the last video and this video that hopefully you're kind of getting an idea. And again, if you're not, rewatch the videos, rework these problems. And once you do it enough, once you get enough practice, and how much practice that is will depend on you. But once you get enough practice, you can see quicker, more quickly, what u should be and what du is and what you need to adjust to make your substitution. All right, so then the last one. So now this one we have two functions. We have ln of x and we have dx over x. Now hopefully you notice that the derivative of this one is this one. So that makes things a little bit easier. So if we let u equal ln of x, du is dx over x, or 1 over x times dx. And so this becomes very easy substitution. It's just going to be u times du. Let's look at the limits of integration. So we have x equals e, x equals 1. So when x is e, u is ln of e, which is 1. When x is 1, u is ln of 1, which is 0. So this becomes the integral from 0 to 1. ln of x is u. dx over x, which is what we have left, is du. So integrate u, we get 1/2 u squared from 0 to 1, and that's just going to be 1/2. So I won't write out all that, but we just end up with 1/2. So which that's not the important part. You need to review that if you need to, if you don't remember from Calculus 1. But we'll be doing that enough that I don't think that'll be an issue as far as evaluating at the limit once you get it. The tricky part is learning how to do these substitutions. If you need help, come to office hours or set up an appointment with me. If you're doing this in the summer term, then I mean this is going to go really quick, and so you don't have much time to waste as far as getting your practice in. So make sure you get your practice in. We're going to be learning a lot more integration techniques, and so this is just going to be one of many that we get to. So you want to make sure you learn this one quickly and well before we get to the next stuff. So all right, if you have any questions, you can let me know.